Hello and welcome. My name is Daniel Mercedes and I'm a product manager at Leuze. In today's video, I will explain how inductive switching sensors work and how they are used. So what is an inductive switching sensor? That is a sensor that detects metallic objects without contact with the help of an alternating magnetic field. Switching means here that only the presence of the object is detected, the exact distance is not measured. This way, for example, steel, stainless steel, copper or aluminum can be detected when they're close to the sensing side of the sensor. So what does electromagnetic induction mean? The basis of induction is the following physical effect discovered by Michael Faraday in 1831. When a magnetic field moves or changes over time, an electric current is generated. This happens, for example, when a magnet approaches a power cable. The effect is enhanced when the cable is wound up as a coil. At the same time, the opposite effect occurs, discovered by Emil Lenz in 1833. The previously induced electric current generates an opposing magnetic field. This influences and dampens the original inducing magnetic field. Now let's have a look at the principle in action. What happens inside the sensor? First, a copper coil generates an alternating magnetic field. Its frequency is controlled by an oscillator. When a metal object enters this magnetic field, an electric eddy current is generated or induced inside it. This eddy current in turn generates an opposing damping magnetic field. This creates a resistance in the oscillator and its oscillation amplitude is reduced. This drop in amplitude triggers object detection and switches the output of the sensor. Each sensor has a nominal sensing distance, measured on a standardized steel measuring plate. However, other metals have different magnetic properties, which is why correction factors are used. In the example you see here, the sensing distance is 10 mm for steel. But for stainless steel it's only 8 mm, and for brass, aluminum and copper it's even less. So for these materials the correction factor is lower and the real sensing distance is reduced. Now let's look at a few applications of inductive sensors. First of all, positioning and position control is very important. For example, in detecting moving components inside machines. Second is presence monitoring or object detection, for example, of carriers of raw production material inside a serial production process. And third is speed or frequency measurement, for example, inside a drive control. When installing inductive sensors inside metal, for example, inside a machine, a few things need to be considered. I will explain this using the example of a cylindrical sensor with an external brass thread. There are two types of sensors. One is an embedded or flush version and the other one is non-embedded or non-flush. You can see the difference in the sensor by the shape and size of the front plastic cap. In an embedded sensor, the coil is located inside the metal housing of the sensor, whereas in a non-embedded sensor, it's offset to the front and the plastic cap is larger and sticks outside the metal housing. Therefore, the first sensor can be embedded in metal. That means that its front side can stay flush to the surface. For the non-embedded version, the sensor sticks out over the metal surface. The difference is now that the flush installation leads to a narrower and shorter detection range for the same size sensor. And the non-flush version leads to wider and longer detection range. Now let's look at a few advantages of inductive sensors. First of all, they detect metals only. So other materials like wood chips, plastic or oil don't interfere with its operation. They work independently of the color and surface quality of the object to be detected. They're insensitive to dust or vapor in the air. And there is no blind zone. That means that even with a distance of 0 mm, the sensor works reliably. Compared to other sensor technologies, the switching frequency is very high, in a range of about 100 Hz up to 5000 Hz. So it's very well suitable for high-speed applications. Inductive sensors are wear-free because they don't have any moving parts, so they can be used for very many years without pause. Due to mass production, the prices are low and there's very many different designs available. Now let's look also at some disadvantages, or what needs to be considered during use. Only metals can be detected, so if it's necessary to detect other materials, another type of sensor needs to be used. The sensing range depends on the metal type to be detected, so that needs to be considered during installation as well. The range is very low compared to other sensing technologies, in the range of a few millimeters, up to typically 40 millimeters. And there can be interference from electromagnetic fields from other inductive sensors or from other external sources. So let's summarize. Inductive sensors generate an alternating magnetic field to detect all types of metals. They are produced by the millions and are used in every single industry. If you want to learn more about our portfolio of inductive sensors, visit our website or give us a call. Thanks for watching.